All right, so chapter 9, last chapter. The first section we're going to probably take like 3 days. There's a lot of information in here, but it's on what's called properties of radicals. And a radical is a square root, like sign like that. You could have third root, fourth root, fifth root, the whole, we're going to do square roots. So today we're going to deal with primarily just two kind of examples. So before we do some examples, it would be a really good idea for you to know the square root of 4 is 2, and the square root of 9 is 3, and the square root of 16 is 4, square root of 25 is 5, square root of 36 is 6, square root of 49 is 7, 64 is 8, 81 is 9, and 100 is 10. Technically, square root of 1 is 1. Probably 6 and under, like these ones, are probably the ones that you're going to see more often. It's not to say that those other ones won't appear. I'm going to show you two ways to do the problem. One way, if you know these, it's going to be a lot easier. And then one way that if the number's kind of a weird number and stuff, that you could still figure it out without like knowing, these as well. So, let me kind of find one. Yeah, so if we had like the square root of 18, and we're going to be simplifying. Should have said that. So basically, when we simplify something, we're going to kind of break it apart. So there's two ways to do this one. You can just ask, what times what is 18? So I could, and 18 times 1 like doesn't count. So 6 times 3, 9 times 2 make 18. But I want to use the one that has a square root in it. So I'm going to use the 9 and 2 because I can multiply square roots together. Like I could get 9 times 2 is 18, like over here. But the 9 has a square root. And so I want to do that. And this square root of 9 is 3. And so 3, we could say 3 square root of 2. That's why we like say that answer. Okay, so what times what is whatever number, but one of them has to have a square root. That is one way to do the problem. The other way to do the problem is to kind of what's called do prime factors of 18. So it's just what times what is 18, and it really doesn't matter what you do. It doesn't have to have a square root. But you have to break down the numbers as far as they'll go. Okay, and so what we have is we have a 3, a 2, and a 3. And I sometimes, like when I break a number apart, I kind of write, like I can still see that's a 6, but it also tells me like, it helps the numbers that I need to use at the end of the problem stand out a little bit more. So 3, 3, and 2. And so what I look for are pairs. Okay, I have a pair of 3's, so I write a 3. I don't do 3 times 3, I just write a 3 because I have a pair of 3's. And then I have a 2 left over, and then whatever's left over goes on the inside of the square root. So I personally think I use both of these methods. I personally think numbers that are 50 and under are easy enough to do the first way. What times what is like that number. Not all the numbers, because there are a couple numbers that are kind of different, but and then numbers that are bigger than 50, for the most part, I would break down using like factors like this. Okay. So like for instance, if I had square root of 72. Like what times what is 72? That, some of you might be able to do that. Some of you, that's going to be more of a challenge. So I'm fine with just starting to break it apart. So when you ask me what times what is 72, the first numbers that come to mind are 9 times 8. And so you could also okay, I can't do anything with the 3. I can't do anything with the 3. And then 4 times 2 is 8. Okay, can't do anything with the 2 or the 2 there, so I'm done. Okay, 2, 2. So then, okay, I got to deal with all the numbers that have a box around them. Okay, so I look for pairs. I have a pair of 3s, so I write a 3. I also have a pair of 2s, so I write a 2. And then what's left over is under the square root. I just have a 2 over here that's left over. And then I would multiply those together for the answer. Okay? So if you had more than one, let's say you worked out a problem and at the end you had a 2, a 2, a 3, and a 5. So you would, whatever the number was at the very beginning, that would be 15 times 2 is 3. It would be 60. Okay? So you broke down 60 and you got this. So again, you're looking for pairs. So here's a pair, so I write a 2. And then the ones that don't have a pair, I write on the inside. And so there's more than one thing on the inside, so I multiply those together. Okay, so if you have more than one pair, like on the one on the right, I have a pair of 3s and I have a pair of 2s. So I do 3 times 2. We're not multiplying 3 times 3 or 2 times 2, just the one number from each pair. And then whatever's left over is on the inside. If you have 2 things left over, you multiply those together for what's on the inside. Okay? So, all right. So some of the, you'll have some just numbers. Some of the problems will involve variables. So a square root of a variable is, we're not doing the square root of the number. So, okay, I'm not square root of 2. There is no square root of 2, but the answer is just an x. Okay, the square root is half. Okay, do you see the pattern? Okay, it's half. So if I had a problem that was x to the 9th power, well, I'm not going to put 4.5. Okay, we don't put decimals in an exponent. Okay, so how I'm going to do that is I'm going to put 1 less. 1 less than 9 is 8. And I'm going to break it apart like that. It's always 1 less. Okay, because I can do the square root of x to the 8th power. It's half of 8 is 4. And then the x is left over on the inside. Okay, so any even exponent that has a first square root, it's just half and you're done. Any odd number, you're going to do 1 less and then leave 1 under the square root because the square root of an even number is half. Okay, so you'll have, looks like 4 problems with some variables. At least in the first set that you're going to work on. So we've got, let's see. So if that was the problem, okay, what I'm going to do is I'm going to do the 48, and then I'm going to do the x to the 5th power. I'm going to do them separate. Okay, so I think a lot of people like this break it apart method. I know one of my own kids does. Okay, so I've got a 2 and a 2. I've got another 2 and a 2. And I've got a square root of 3. So remember to multiply those together. Okay, and so just the 48 part, I get 4 square root of 3. Okay, then the x to the 5th part, 1 less, and half of 4 is 2. Okay, so just the x to the 5th part is that. And then I combine these two for my answers. So 4 is on the outside, and x squared is on the outside, and then 3 is on the inside, and x is on the inside. So my complete answer is the green part. Okay, so there's nothing any like super crazy going on. If you can do the square root of a number, then do it. Like, so a couple of them I'm looking at actually have a square root. So like underneath, instead of 48, it might be 36. Oh, square root of 36 is 6. And so you don't have, then you have just a letter underneath the square root. Okay? All right, so one set of problems to do with just that. Then your second set of problems is going to be, okay, like some dividing ones. And there's a bunch of stuff that kind of goes with the dividing ones. But we're just going to do one part today. Okay, so you're allowed to break apart the square root like that. Okay, square root of 9 is 3, square root of 25 is 5, and that would be the answer. Okay, you could have so square root of 10, square root of 49. There is no square root of 10, and square root of 49 is 7. Okay. A couple of them have like a negative sign in front. Okay, so square root of 4 on top and square root of 81 on the bottom, but negative still in front. So I get negative 2 over 9. Okay, so some of the second group of problems you're going to do are going to have both numbers that have a square root. And then some of them will have a square root on the bottom, but not on the top. And so that would be like this second one where we had square root of 10 over 7. Okay, you could have so like with a variable. Okay, so the easy part's the bottom. Square root of 16 is 4. So remember, I can't do the square root of the odd number, it only evens. So I go 1 less, and leave the extra one under the square root. Square root of x squared is half. Half of 2 is 1. Okay, so you treat the variables the same way. If they're on the bottom, then leave them on the bottom. If they're on the top, leave them on the top. If they're an even number, then the square root is just half. And you just do it, just like, 16, square root of 16 is 4, square root of 81 is 9, square root of 4 is 2. You just do the square root if it's even. If it's odd, then you break it apart like I just did there. Okay, so tomorrow we'll talk about like what happens if there's a square root. So all your problems today, there's no square roots at the end in the denominator, only the numerator. Tomorrow we'll talk about what happens if there's a square root in the denominator. Okay, and what to do with that. So we're going to kind of, like I said, break this up into pieces. Okay? All right. Have a great day, guys. We'll see you next time.